All right, so in piecewise graphs, we're looking at different components to find different parts of the picture. So in this first example, we have x less than 0 and x greater than or equal to 0. So the 0 seems to be what's called a transition point. That at 0 we switch from the top equation to the bottom equation. Okay, so we're going to start with just functional values then. This first example, f of negative 2, I would find that by looking at the top equation. So if I want to find the functional value, in other words, when x is negative 2, what is y? That would be negative 2 minus 3, which is negative 5. So that has a y value of negative 5. Whereas f of 0, 0 I get, again, looking at these symbols, it seems to be at the top equation. It's greater than or equal to 0, which means 0 is part of the bottom equation. So negative 0 plus 2, which means when x is 0, y is 2. And then f of 2, which means when x is 2, so that would be negative 2 plus 2, which is 0. So when x is 2, y is 0. Okay. Now a couple of different techniques. One approach we can do is we can just go straight to 0 and just plot points and kind of talk through this. So at 0, there's actually two y values there. One of them is an open circle, one of them is a closed. So at 0, for the top equation, I get 0 minus 3. So at negative 3, I have an open circle based on that top equation. The bottom equation, which we already figured that out, at 2, I have a closed point. Okay, and then I'm just going to look at y or x values and find y values that correspond. So like at negative 1, at negative 1 would be in the top equation. I would expect to see something like negative 4, so I'll put a point there. Negative 2, we already know negative 2 is negative 5. And so we can see very quickly that this part of the graph is a line that's got a slope of 1 and a y-intercept of negative 3. So I can sketch that in. And then on the bottom equation, do the same technique. So at 1 would be defined by the bottom. So that'd be a negative 1 plus 2, so that puts it at 1. At 2, we already know we have 0, so I get another line that's going down in this way. So that's what our graph of this first thing looks like. So it really does help to stop and look at the transition values, where the open and closed circles are, and then what is the things, these ordered pairs here. All right, so number 2. In number 2, let's see, negative 3. Negative 3, I get, it's smaller than negative 1, so when x is negative 3, that just tells me that y is 2. There's just no math at all in that. Just read that and look. At negative 1, so if I evaluate this at negative 1 has a or equal to piece, so that means the bottom part is with it. So it'd be the absolute value of negative 1 plus 2, which is positive 1. And then f of 1 would be again by the bottom, defined by the bottom equation. So that would be absolute value of 1 plus 2, which is 3. Okay. And then I'm going to go back to this transition. And at the transition of negative 1, there's an open circle at 2. And pretty much anything smaller than negative 1 is going to have a y value of 2. So I can go in and fill in that straight line right there. And then the bottom equation, which does have a closed circle, at negative 1 has a closed circle at positive 1. And then I can just fill in points from there. So at 0, I'm at 2. At 1, I'm at 3. So it's got a positive line going that way. So that would be what, number 2? Okay, so in number 3, we got a little bit more complicated looking piecewise function, but not that bad. This time our transition value is around 0. So where do I find f of negative 2? Well, negative 2 is smaller than 0, so that would be defined by the top equation. So that would be 2 minus negative 2, and that value would be at 4. 0 itself, so 0 would be defined by this middle. So when x is 0, y is negative 2. And f of 2 would be anything bigger than that. So that would be 2 squared, which is 4. And then going to our little graph here. So at 0, I have an open circle. I'm looking at the top equation now. So 2 minus 0 is 2. So at 2, I have an open. And then as I go to negative 1, I'm at 3. And as I go to negative 2, I'm at 4. So it looks like I've got a straight line going that way. Then the middle equation, when x is 0, y is negative 2. That's a closed point at negative 2. And then the bottom equation, when x is 0, I get 0 squared. So that's another open circle there. And then now it looks just like the parent graph. So at 1, 1, 2, 4, 3, 9. Oops. Connected that to the wrong piece. Yeah, I gotta be careful with that. Alright, so it's connected off this open circle here. And there's an arrow going that way. So that's what our piecewise looks like in number 3. And then number 4 is the last one. I'll kind of hold your hand and walk you through. So looking at negative 1, that I get from the top. So that'd be negative 1 cubed, which is negative 1. 1, okay, looking at the symbols, 1 x is greater than or equal to 1, so that would be at the bottom equation. So negative 1 squared plus 2, which is 1. And then 3 I get from the bottom equation, because that's when x is bigger than 1. So that'd be negative 3 squared plus 2. So that's negative 9 plus 2 is negative 7. Okay. All right, and then we're going to go to our graph. So our graph, when I go to 1, I get an open circle at 1 for the x cubed piece. And as I continue to plot points, at 0, I get 0. Again, I'm looking at just the top equation. Negative 1, I get negative 1. Negative 2, I get negative 8. So it looks like a cubic going down that way. The other one, so at when x is 1, the bottom equation, where it's a closed point, I actually, oddly enough, get the same x value. So what was open is now closed, because if you have an open circle and you put a closed point on top, then can you see the open? No, you can't. Hold on. Okay, so continuing on, when I'm at 2, well, I'll go all the way to 3. At 3, I'm at negative 7. 3, I'm at down here, negative 7. Just to kind of give me a transition point in between. When I'm at 2, I'm at, what's the negative 4 plus 2, so I'm at 2. Negative 2, sorry. Okay, and then so that piece would connect like that. So it kind of looks like a parabola, but not really. One half of it is based off a cubic and one half is based off a quadratic, so they're not quite the same. So anyways,